Hey there, when you look at the periodic table, you see this huge divide between the metals on one side and the nonmetals on the other. But what is it really? What's the one deep down atomic secret that makes a piece of iron so different from, say, the air we breathe? Well, today, we're going to uncover it.
Here's how we're going to break it down. First, we'll look at the obvious differences, the textbook stuff. Then, we'll have some fun with the elements that love to break those rules. After that, we'll dig into their chemical personalities, which leads us to the grand finale, the great electron exchange.
All right, let's start with the basics. These are the classic traits you probably learned in high school science class, the things that let us sort metals from nonmetals just at a glance. So, you know the drill? Metals, they're the shiny ones, they're usually hard, you can hammer them into thin sheets or draw them into wires, and they're amazing at conducting heat and electricity. Nonmetals, on the other hand, are kind of the opposite in every way. They're dull, brittle, and really bad conductors. Pretty straightforward, right? And when we talk about being drawn into wires, their ductility, it can get pretty extreme. Get this, you can take just 1 single gram of gold and stretch it into a wire that's 2 kilometers long. That's over a mile. Absolutely wild. Okay, but here's the thing about science. As soon as you learn the rules, you find all the cool exceptions. And this is where it really starts to get interesting. So, we just said on our chart that metals are hard. You think of things like steel or titanium, right? Strong, tough stuff. But is that always true? Not even close. Meet the alkali metals. You could literally take a block of sodium and slice it with a dinner knife like it's soft butter. And then you've got these weirdos like gallium. It's a solid metal, but if you hold it, your own body heat will melt it into a silvery puddle in your hand. And here is the biggest plot twist of all. What's the hardest natural thing on the planet? It's not a metal. No way. It's a diamond. And a diamond is just a special arrangement of carbon atoms, a total non-metal. And the rule breaking doesn't stop there. Lead is a heavy metal for sure, but it's a surprisingly lousy conductor. Meanwhile, the graphite in your pencil, which is also just carbon, a nonmetal, can conduct electricity pretty well. So clearly just looking at physical properties doesn't give us the whole story. Okay, so if how they look and feel can be so misleading, let's talk about how they act, their chemical behavior. This gives us a much better clue about what's really going on. A really classic chemical test is just to see what happens when they react with oxygen. When most metals do this, they form something called a metal oxide. And the key thing here is that these oxides are usually basic, which you'll remember is the chemical opposite of being acidic. But of course, they don't all react with the same enthusiasm. You've got sodium, which is so desperate to react, it'll just burst into flames in open air. Then you have aluminum, which reacts instantly but forms a super tough, invisible layer of oxide that actually protects it. And then you've got gold, which is so chill, it just doesn't react at all. It stays shiny forever.
Now, let's flip the coin. When nonmetals like carbon and sulfur burn in oxygen, what do they make? Acidic oxides. So here we have it, a clear chemical dividing line. Metals tend to form bases, nonmetals tend to form acids. They are true opposites. This is a huge clue.
So, why? Why all these differences? Why the exceptions? Why are they chemical opposites? The real answer, the fundamental secret, isn't something you can see or touch. It's happening deep down, at the atomic level. It all comes down to one thing, the ionic bond. You can think of it like a perfect deal. It's a super strong connection that forms when one atom gives something away and another atom takes it. And here it is, the secret itself. Metals are atomic givers. They've got a couple of extra electrons in their outermost shell, and they are dying to get rid of them to become stable. Nonmetals are atomic takers. Their outer shells are almost full, and they are desperate to grab an electron or two to feel complete. Watch this happen with regular old table salt. Sodium is a metal. It has 1 electron it needs to ditch. Chlorine is a nonmetal. It needs just 1 more electron to be happy. So, the electron makes the jump. Sodium becomes positive, chlorine becomes negative, and boom, opposites attract. They lock together with this incredibly powerful force, and that one simple transfer, that powerful bond, explains everything. It's why salt is a hard, brittle crystal. It's why it has a crazy high melting point. You need a ton of energy to break that attraction. And it's why solid salt doesn't conduct electricity. The charged ions are locked in a cage. You have to melt it or dissolve it in water to set them free so they can move around and carry a current. So, a giver and a taker make a perfect partnership. It's a complete exchange. But that leaves us with one final, very interesting question. What happens when two takers meet? Two nonmetals that both want to grab an electron, but neither one wants to give one up. What kind of deal do they make? Well, that's a story for another time.